Good afternoon, everybody. Hi, my name is Leishman. I work at Neo4j. Before we start, just one point of note, what's on your agendas actually says we're doing a graph modeling talk. What's on the website says we're doing a Success with Neo4j talk, so there's a slight mismatch there. I'll cover modeling very slightly, but just to set some expectations, we're mostly going to be talking about my experience with people trying to become successful using Neo4j. Of course, I'm happy to take as many questions as you have around modeling and all of those things, either during the talk or afterwards as well. So we'll go into that. So welcome. Welcome to GraphConnect. I hope you've all been having a good day. I hope you've got some coffee in the quick break and you're all alert and ready to go. So we might as well get started. I think most people have filtered in, so good. As I said, my name's Leishman. I've been with Neo for about 4 years, and I've done many, many different things. What I've spent a lot of my time with is looking at our customers and our community and understanding what's made people successful with their journey into graphs and what's created some challenges along the way. And today I want to talk about what I've seen that people do that make them quite successful. Following my talk, and I don't know if he's in the room, but my colleague Stefan Armbruster will be doing the counterpoint to my talk, which is the worst things you can possibly do. So I encourage you to stick around for both. They're kind of designed to go together, and you'll get a nice balance of how to really get to where you want to be. So, who's currently using Neo4j for something in a production environment? So we've got one. Anybody else? Another one over there. All right, I'm going to start with you, sir. Here's a microphone. Just can you tell me why you chose to use Neo? What attracted you to it?
Well, it's representing a lot of different relationships, primarily through customer and product hierarchies.
Okay, thank you. And we'll do the same over here as well. So what brought you to Neo? What made you find that the appropriate solution for your problem?
So a lot of its traversal capabilities, it represented very well the Ancestry product that we actually had a speaker give earlier today.
Okay, thank you. Anybody else using Neo in production? Nobody? We've got all these new people? Great, well you're in exactly the right talk. We can turn this off. I'll just leave it here. Okay, so I've asked you guys why you chose to use Neo. That's really a question that I should answer as well. And I've worked at Neo for quite a while, so I've got an interesting perspective on that. You know, why did we create Neo? Why did we get interested in this graph thing before anybody was really even paying attention to this space? Why did we do that as an organization? Like, what were we thinking? What were we trying to achieve? And really the question there is not why did we build Neo4j, but why did we do what we do? Why are we here trying to do what we're doing? And it's really quite simple. It's because we fundamentally believe that there is a better way to work with data. And it comes back to exactly what these two gentlemen said, and you know, I could ask anybody who's using Neo4j or any graph database in production, they say the same kind of things. It's because there's a fundamental difference in the way we want to work with our data. And that's really, if you listen to Emil's keynote this morning, that's how their business started. That's what he recognized when they were trying to build the system they were trying to build. They just needed a better way to work with data, and that didn't exist. And really, that's the fundamental reason Neo4j, or Neo Technologies, the company, exists. It's because of this fundamental belief. And we believe that the key to doing that is to focus on the connections that exist in that data, on the relationships. That's what leads us to graphs, but it's more fundamental than that. It's really about looking at the kind of data we want to work with and the way we want to work with that, and focusing on those connections, those relationships, as opposed to having everything disconnected and separate like we were doing in the past. And we believe that that gave us a much more natural way to work with our data, a much more helpful way to work with our data. Because at the end, if we divide everything up, yes, we have information, but what we're really after, what we're really trying to do when we're working with our data is we want knowledge, we want insight into that. And so the connections are absolutely fundamental. in the past we've had very divided data sets. We've had, good tabular structures. We can store all our information. We've got our, in this particular example I like to use, we've got some flights and we've got some airports and we've got some cities and all the information is there. And yes, we can work with that. We can write queries on that. All of those exist. And our queries obviously have to understand how that data is connected. That this particular key references that foreign key and this primary key references that other foreign key, and the connections are all there. But it's just not a very nice way to work with our data. It's just not, it doesn't help us understand it. It doesn't lead us in the right direction. It doesn't give us a good experience. Versus exactly the same data, I can draw like that. And now it's very clear what I'm talking about. If we look at this, I'm sure some of you can look at that and see the same thing with a bit of mental effort. If we look at this, it's just obvious to everybody immediately. So we wanted to focus on that domain. We wanted to focus on how those things are connected, how those relationships exist, what they are, what they mean, rather than on the way we store that stuff. And historically, for lots of very, very good reasons in the past, we've focused on how we store and we retrieve data versus on what that data actually means, what's the domain. And a very good colleague of mine, Alistair, who's probably upstairs, actually no, Alistair's not here this week, sorry. But he came up with this model, and this is what we call the relational crossroads. On one hand, we have the kind of NoSQL path that a lot of people are going. Your relationals in the middle, and we've gone to the denormalizing, the Mongos and the Reacts and whatnot, which have tried to simplify the storage. Let's simplify how we store that data so that we can divide it up, we can spread it around, we can do, far more, rapid retrievals and, updates. Much, much simpler, very MapReduce friendly. So everybody who's been in the big data industry is, obviously very happy with MapReduce friendly kind of things. But it's losing something in that process going in that direction. On the other side, in the other direction, we've got a richer model, a more connected understanding of our data, good structured data, very, very expressive power in that, and really fast traversals through that data. And so while the NoSQL community is out there and they're exploring this sort of denormalization approach and how can we simplify our storage, we're interested in going the other way and exploring that path. Seeing what it means to simplify the understanding instead. And that's kind of how we've arrived where we are. And we fundamentally believe that's a better way to look at data. Whether everybody in the world agrees with us, we don't know. But that's what we're here to find out. And so way back when Emil was doing this, and he had his problem that he was trying to solve, he was curious about, he wanted a better way to build software using the model that he had. He had this very hierarchical model. In fact, there was probably some loops in there and things, and he needed a better way to build the software he was trying to build. And so once he had that experience, we wanted to then enable others to do the same. And that's really how we get to where we are today. That's how we as an organization got to be here, and that's why we built Neo4j. So with that understanding of why we're here and what we're trying to achieve, I wanted to give you guys sort of my top 8 tips on how we can get from where we are now for a lot of you, which is 0, through to being extremely successful with a product like Neo4j. Some of this has been covered in much more detail by some of my colleagues in earlier talks, and some will be covered in much more detail afterwards. That's okay. A lot of you probably weren't in the room earlier, so we'll go and I'll take questions along the way and we can have a good conversation. So, tip number 8, and I'll work down. My tip number 8 is to use a rich data model. And for those of you who were interested in data modeling, I can talk a bit about that. Also tomorrow, we've got tutorials running all day on specifically how to do data modeling. I really encourage you to go to those. They start in the morning, they run all day, and I think there's actually several of them running. So if you're not booked in, talk to someone and see if you can get booked into those. Fantastic way of going about it. Also upstairs, the Graph Clinic, the guys up there have got whiteboards and things, and they're more than happy to help you with your data modeling along the way. Because graph modeling has to be learned. And I could sit up here and I could try and talk you through it, but it's much, much better if you can sit down with one of us and you can say, here's my problem, let's try and understand it. Because what we'll first off do is we'll ask you about your domain. What is it that you do in your business or in your problem that you're trying to solve, that you're trying to model with? And that's really the key first step to any successful graph modeling project, is to understand the domain. And by the domain, I mean the business domain that you're in. It's what are the things that exist in your data? Is it people? Is it seeds, if you happen to be in Santo? Is it products, if you like? Is it things you're going to purchase on a website? Is it people in a social network? Is it friends and relationships between people? It's all of these kind of questions that are going to come out, and we're going to talk about those. For the software engineers in the room, there's a really good book called Domain-Driven Design. If you haven't read it and you're a software engineer, do yourself a favor and go and read it. It's one of those kind of things that every software engineer should have on their bookshelf. Interestingly, a lot of the concepts in that book apply to graph databases as well. And this is an interesting observation for the software engineers in the room, because what that means is that the models you use in your software, you can also use in your database. And this is not true of what we were doing before. We had to go through this mental abstraction where we move from one to the other, and we have to translate between our nice, rich domain model and our tables, and back again. This is really powerful. Being able to use the same concepts in both layers not only simplifies the code, I mean, that's one thing, but it simplifies our understanding. It allows us to talk about what's going on in our domain right down to what's happening in our database without having to confuse people who may not know database technology. And in doing that, we also understand the relationships in the data. That's really key to all of this, is not only understanding the entities that exist, the people, the products, the genes, or whatever it happens to be. You can tell I went to the seed and gene talk earlier. It's also the connections between them, because that's the fundamental thing that makes the data interesting. It makes it, gives us the information we're looking for. And so, like I said, I could sit here and I could tell you all of these things, and we could sort of talk through the different models and different things, but it's much better to get a whiteboard and talk about your domain and draw it. And one of the amazing things you'll see that happens is you can take almost everybody, give them a whiteboard and give them a pen, and ask them to talk about the problem they have, and they will draw a graph. I've been 98% successful with this. The one or two times I haven't been successful with it is when I've asked a finance person. Don't ever do that with a finance person. They just think in spreadsheets all the time. It's quite fascinating. But for most people, if I'm talking to you about the flight I had to take from New York to San Francisco the other week, I'm going to draw a graph. I'm going to say, well, I had this flight, and the destination was JFK, and the origin was San Francisco, and shit, as usual, it got cancelled by something. And I'll draw a graph to try and describe that to you. And you'll find that person after person after person, given a whiteboard and a pen, will do exactly that. And the nice thing about that, when you're using a graph database, is you can literally just translate that into a few expressions, add some conditions in to constrain it to what you're interested in, and you've already started to model that in a database. You want to go back? These slides will be available, as will the recording, I believe, so I'll walk through it again slowly, because it's just a nice, that's literally what you're doing in order to take something that a business person or somebody who has no technical skill, given a pen and a whiteboard, will draw, and now you're turning it into code you can run in a database. And that's what we mean by having an easier way to work with data. And then, of course, the best way to get really good at modeling is to study. We have lots of information on our website. So I suggest everybody grabs pen and paper, because I'm going to throw links at you and references at you. These slides will be available as well, so you can get the links later if you don't manage to write them down. But getting started on our website, in fact, the whole developer section has a lot of good information on this. And this is a really good way to learn in addition to grabbing some of our people while you're here and going through that modeling. Of course, the very best way is to copy others. The very last thing you want to do when you're starting a new project is look at what some other people are doing and understand that and consider it as very nice and then go, well, that's interesting, and get a whole blank piece of paper and start from scratch and do it all over again. It's crazy. What you want to do is copy. Just blatantly copy as many people as you possibly can. This is the way to success in all endeavors. Figure out what your value add is, but for everything else, just copy. Unfortunately, we've made that really, really easy because we put a lot of information on our websites. We collect a lot of things from our community. We share them back. We've got great resources like all of these, examples of different graphs in different domains, and there is dozens and dozens and dozens of them. In fact, it just keeps on going. And all of these are available on our GraphGIS site. So if you haven't seen that resource before, go and have a look at it after the talk. There is literally dozens and dozens and dozens of examples of graphs in all sorts of different domains, from racing through to water sports, through to libraries, through to all those ones that you saw up there. It's a great collection of things. And of course, if you have your own, contribute it and share that information as well. Okay, so modeling. That's all I've got on modeling. If there are questions, of course, I'll take them. Jump in any time, or we'll take them at the end, or we'll take them over beer later. It's up to you guys. My tip number 7 is to use Cypher. I mean, the whole point in us building Neo4j was to give you a better way to work with data. Cypher is the best way that we've come up with thus far. Who knows, we may come up with something even better later, but right now we believe that is the best way you can possibly work with your data. So use it, but use it carefully. So for those who don't really understand this whole Cypher thing, who are new, who might not have had much experience in graphs before, Cypher is the declarative pattern matching language for connected data. So what do I mean by the declarative pattern matching language? What that means is it's a language where you describe what you want. Rather than telling the database to do something specific, you describe what you want to get out of it. And pattern matching, well, that means what we're doing is we're describing its patterns, things that we're interested in that data, and then asking it to go and match those, to find those and bring them back. So that's really, in essence, Cypher is a declarative pattern matching language. And what that's all about, well, it's about not having things like this, which is the query that I would use for the very simple example I had before for figuring out why my flight was delayed. So we don't do that, but instead we do the query I showed you a minute ago. And I specifically describe the pattern I want, which was literally copied off the whiteboard, and then I add in the specific data points that I'm interested in, like the fact that it was flight UA98, and it was from SFO, and it was to JFK, and I'm interested in understanding all the possible reasons that flight is always delayed, and then give me back a summary of that. Thank you very much. So use Cypher. It's amazing. It's amazing how easy it is to get this kind of information out of your data once you've got a language like this at your disposal. And it's really, really great for structured data, for things that are connected. Because it is about that pattern matching. It's about showing, asking about how things are connected and to get back results based on those patterns. It's not SQL. It looks a bit like SQL, and that can sometimes lead people astray. Because you start going, oh, well, SQL, you do it like this. It's not SQL, so be a little careful there. It does use a lot of the same concepts. It was inspired by SQL, but it's different. And it helps to learn the differences. There is a great guide, again, on the website on going from SQL to Cypher. So all you DBAs in the room who spent your whole career learning SQL and are like, bloody hell, people think they can come up with a new language and going to make my life miserable. Well, we're going to try and help you along the way, and it'll be worth it, believe me. There's also the Cypher Developer Guide. Developer Cypher, there's lots of information, ref cards, interesting examples of how you can do certain complicated things in Cypher, and there's all sorts of different ways you can use Cypher, and that's all covered in there. There's good talks and blogs and things out there on understanding how Cypher queries are evaluated. If you were in the room just before 2 talks ago, there was a great talk by my colleagues on exactly this topic, on how those Cypher queries are evaluated, how the query planning is done, how to understand the performance implications. If you weren't here, just download it on the website in a couple of weeks when the video's up and watch it, because that'll give you a lot of insight. Those are the guys who literally work on this day in and day out. And of course, there's a documentation for the language. All of this information is on the website. That's going to be your greatest resource when you're trying to learn the differences between SQL and Cypher. There's also, in the actual product, there's details on using Cypher and how to go from SQL to Cypher. So that we've got this whole Northwind graph. I don't know who's familiar with the Northwind dataset. It's a pretty famous dataset in the relational database community. When you download Neo4j and you start it up, you can literally click through, as I just showed you there, and load that dataset into Neo4j and start working with it. So those of you who are used to working with relational databases, this is a really good introduction to help you show how to move from one to the other. Cypher does have its own quirks. That's why I say carefully. And it's being constantly evolved. We have a whole team of engineers who's developing this over time. And as we heard this morning, it's now going to be an open project. We're going to be inviting collaborators to that. We're going to be having more implementations out there. And that's going to drive that evolution. I fully expect some things to change, hopefully for the better. But it's just something to be aware of and to be careful of those quirks. For an example, one of the quirks which I know bites everybody is Cartesian Products. And they got mentioned a little bit in one of the earlier talks, and I think it's worth covering again. For those who are not mathematicians, don't worry, I'm going to show you what a Cartesian product is. It's when you write a query like this, which looks pretty obvious. It's match person A and match person B and return them, please. So I want to get 2 people out of my database. Seems reasonable. And it is reasonable if there's 2 people in your database. Almost. Because even if there's 2 people in your database, there's actually 2 different results you can get from that. There's person A and B, and then there's person B and A. It's this kind of set theory. It's something to be aware of. And of course, that gets exponentially bad. If there's 3 people in your database and you do this 3 times, well, now you're going to start to get things that look like this. And very, very quickly, you can get billions and billions of results from what looks like a very simple query. So that's my biggest tip on Cypher. Be careful of Cartesian products and use the query planners that are there to understand what's going on. Avoid large result sets that build up in memory. I mean, that's what the Cartesian products produce. Lots of other queries can do the same. They can build up these very, very large result sets in memory that will chew up all the memory on your box, and you'll be sitting there going, why is my query not returning, and why is everything else trying to access my database not able to anymore? It's probably because you had a query that just used up a huge amount of memory. So again, trying to understand these, and again, there's some great information on that link there about the streaming APIs. There are ways to work with Cypher such you can stream that data back rather than building up large result sets. Use that, understand that. Indexes. Make sure you're using labels on your queries. So when you're writing Cypher, on all those queries, on the nodes, you can describe the labels that go with that. And the labels are essentially, it's a way of typing. It's a way of saying, well, this node represents something of a particular type, be it a person or a product or, whatever it happens to be in your domain. We use that though, as in we as the database, we use that as a way to hook into indexing. And indexes are used for finding things in the graph. Given no other information, if I want to find a specific node in the graph, I'll use an index. That's the only time I use an index in a graph database. I don't need to use that as part of the querying, for joining and all of that. I only need to use it to find those start points, but it's really important for finding those. And without using an index, then I have to search through the entire data set. There's a question? Sorry, I'll pass this over. Oh, thank you.
So can I simply just think of the label as being an alias to the particular object or the node that you're referring to?
I didn't quite understand that.
Can the label simply be recognized as an alias
As an alias?
to the node? Because you're referring...
Not really, although, well, so what you can do is, of course, if that label only exists on a single node in the database, then yes, it's effectively an index at that point. And the reason for that is because whenever you use a label in Neo4j, you apply a label on a node, there's an implicit index that gets created with that. And that's what we call the label scan index. And that basically lets the database find every node in the database with that label on it. If there's only one, that's a really quick thing to find. It's like, okay, well, there's the one, great. Then, of course, you can add additional indexing on that where you say, well, for this label and this property, now look up based on that. That's when you create indexes like this. So with my example data I had before, if I wanted to often look up airports by code or flights by name, I'm going to add an index for those because I'll start my queries at those points. And so now when I write my query that I had before, the database is going to look at that and it's going to go, well, great, Chris, you've got an index on flight names, and you've definitely got a node in there that's a flight, and you've told me its name. So that's an option for me to start looking up in my graph. It may not use that. It may actually instead use the airport codes because there's two nodes with airport label, and I've also indexed the airport code. It'll make a choice between those based on statistics and a bunch of other things, and it'll use those indexes. To understand which index it chose and whether it chose the right one, there's the profiling. And there's another question up the back. Thank you, Alex.
I have a question. So if I have multiple, is it better to have multiple smaller indexes or one larger if I always will be looking for at this one small part of the data set?
Mm-hmm.
I don't know if you understand me. So let's say I have, I can do an index per user on a particular field for the nodes belonging to this user, or I can make one big index for all users and prefix the value with user ID, for example.
So
which one?
So there's
better?
certainly overhead to having an index. So every index that you create needs to be maintained. It needs storage on disk. So there is overhead to those. They have to be, considered when doing query planning. So I would probably, personally, I would avoid, say, having an index per user, mostly because I don't know how many users there's going to be. So now I can have a potentially infinite number of indexes. But in certain domains, that might make perfect sense. I mean, if there's only ever going to be those 5 users in your database, then maybe it makes sense to just have 5 separate indexes and use separate labels for those. Again, this is where we want to grab a whiteboard, understand your domain, draw it up, and walk through those queries. Literally go, all right, I want to ask this kind of question. What's the query going to look like? And what's the best way to find those start points in that query? And that's where you get your indexes from. Good question, thank you. Profiling. There's a question down here. Alex, can you be my assistant? Thank you.
How sort of clever your indexing is. For example, if I have a property called gender.
I'm sorry, say that again?
Let's say there's a property called gender,
yes.
sex. Whether, say, it can only take binary value, of course, let's say, just for the sake of argument. If the 99% of them just male and 1% is female, can your indexing take into account the distribution of that data? So it will only index the female, which is only 1%, rather than all the males, 99%.
So the implementation of the indexes in Neo, right now it's all based on Lucene, so I imagine it indexes everything. I mean, in that particular example, there's no reason it couldn't only index the ones that aren't there. That said, there's always 3 values. There's true, there's false, and then there's the property doesn't exist at all. Which actually, in the enterprise version of 2.3, we now have property existence constraints, so you can avoid that condition. But I don't think the indexes take advantage of that right now. Fortunately, that's not something you probably don't need to be too concerned about until you get into production and you start to really worry about those very, very minute details. Yeah, exactly. Yeah. So using profiles is really good. Talk earlier covered that really well. It's a great tool to understand what your queries are doing and where the costs are, and then you can work with our team and with the documentation to really adjust those and figure out how to really improve your queries. Cypher is a really expressive language. We think it is. We find working with it to be a really expressive way of working with data. A very, very powerful way to work with data. The kind of queries that we find we can write with Cypher is much, much beyond what we could do in SQL. But it's not for everything. And this is coming back to what I said before about using Cypher carefully, because you can do horrible things with Cypher, just like you can with SQL. So just like I said with SQL, don't do this. Yes, this is probably, the equivalent of this in SQL might be 20 pages, but that doesn't make it good. So rather than doing that, this particular one is an example we got from somebody, and I tried to anonymize it a little bit. But essentially, it is broken up into many, many separate pieces of information. Cypher is fantastic. It has this great ability to be able to take many, many separate queries and chain them together into kind of a data flow. It's kind of a very advanced usage of Cypher. It's all brought about by the with clause. You can see a with clause in there. There's a with clause up in there that allows you to chain things through. That can be really helpful in some cases, but don't take it this far. That's clearly getting a little insane, so don't do that. Break it up into separate queries. There is nothing wrong with having, using a database to run more than one query. You don't have to do everything in one shot. It's kind of this anti-pattern to try and build your entire application in your database language. Unfortunately, a commonly seen anti-pattern. Or, tip number 6, don't use Cypher. Carefully. So, like I said before, we think Cypher's fantastic. I mean, so much so that we're sharing it with the world as of today. But we don't think it's for everything. We're not that, we haven't drunk that much of the Kool-Aid. We do understand there's lots of things, and I can think of a dozen examples right off the top of my head that are hard to do in Cypher right now. And maybe in future they'll be better in Cypher, or maybe there'll be some other way of doing them. That builds on top of Cypher. I don't know, but right now I know there's some things you can't do well in Cypher. And we can talk about some of those if you like later. Fortunately, we built Neo4j for developers. Neo4j was originally written as a driver, like an embedded database you could include into some Java code for a developer then to go and build stuff on top of. It was built for developers, and that's still true today. Cypher is kind of the very, very top surface of Neo. It's the most kind of high-level thing you can interact with. We still have a REST API. We don't talk about that much anymore, but if you go and look in the documentation, everything in the graph is exposed by this REST API. You can do a REST call to get back an individual node or an individual relationship. There's a traversal API that's built into that takes traversal descriptions written in JavaScript and allows you to apply that traversal through the graph and bring back interesting information. It's like a much more procedural way of working with the graph. There are built-in graph algorithms that are available over that REST API, so things like shortest paths and A-star algorithms, and a bunch of them are built in. You just one HTTP call away and you get the results back. Then, of course, there's the Java API, and I'll talk about this a bit more in a second, but that gives you very, very specific low-level access to the graph. And then, of course, below that, don't go there. There are things down there, but no, don't. If you want to be successful with Neo4j, I highly advise you don't go there. So those Java server extensions, don't fear them. I know a lot of you aren't Java developers, nor do you ever want to touch a line of Java in your life. That's fine. But don't fear them. I mean, they are there to solve a specific problem and solve it extremely well in some cases. You know, we've worked with many, many customers and taken queries that perform okay, written in Cypher, but they have expectations or particular needs that are well above that. And we help them to implement the same in those server extensions for a vast increase in performance. Those Java extensions really can, they give you very, very fine-grained control on how everything is done when you're running that query. And of course, that's going to allow you to optimize it well beyond anything a declarative language can do. Unfortunately, my colleague Max Damarzi is not here today because I was going to heckle him. But he is like our guru of writing Java server extensions. So he goes out and works with our customers all the time, and almost always his answer to any problem is to write a server extension. Which some of us might think that that's a little scary, but it gets the job done, and that's the important thing. Fortunately, Max is also a very prolific blogger. His blog is mentioned on the slide there, maxdamarzi.com. And there is lots and lots and lots of really detailed, interesting things on his blog about getting the most performance you can out of Neo4j. There's a whole set of articles on how to write server extensions. There's a bunch of other articles that go down into those layers where I said dragons were. So, don't do everything that Max says on his blog. There is a bunch of things on there that I even look at and go, oh my God, I hope nobody ever actually does this because I don't want to have to support that. But things like server extensions, absolutely. Read what he's written. He's written some amazing things there. And he goes into the detail. Like writing a server extension, like I said, don't be scared of it. It's as simple as that. I mean, there's a piece of Java code you could compile and load it into Neo4j right now, and you've built a server extension. And this is a very simple one. It's when you call the HTTP endpoint /service, you get back the string hello world. It doesn't really do much. It doesn't work with the graph. But you've built it into the database now. The database is doing something specific that's tailored to you. And of course, extending that a little bit further to actually do some work with the graph is really quite simple. I mean, here is Max's classic one that he uses in probably a dozen customers around the world, which is his warm-up routine. And this is just, basically, it's an extension. You hit the /warmup endpoint, and this server extension just iterates through every node in the graph. Just loads it into memory and then lets it go again. All that's doing is bringing everything, all those pages off disk into the page caches and warming everything up. And at that point, it's warmed up, it's ready to go, and you're going to get the best performance you can. So these are really simple. Using them, it's as simple as that. Just you type that in curl and hit the endpoint and off you go. I mean, this is what I mean by Neo4j is written for developers. We provide these kind of facilities to make your life really, really easy. Warmed up and ready to go. So, with great power, of course, comes great responsibility. So, don't use Cypher carefully. Tip number 5, and this is the one that everybody misses. Do performance testing. Ian was up on stage earlier, before I was, to talk about how we do performance testing at Neo. So we do quite a lot of performance testing to try and understand how Neo behaves, how to adjust it. Is that my 5-minute sign? Great. I better hurry up. All right, so we do a lot of testing at Neo to try and understand the performance implications of our product. We can only do it on what we know and on the data we have. Your queries and your data is going to be entirely different. the number one thing that everybody misses when they're trying to, get their thing into production and they're really, really excited and they need to get it out there is they don't do performance testing, and then they wonder why things didn't work out the way they did, and then we have to rush at the last minute to try and figure that out. Performance testing will make your life much, 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 much easier. Again, I can go into the detail. Gatling is a great tool for doing performance testing, and again, my colleague Max has written up awesome blog articles on exactly using Gatling with Neo4j for doing your performance testing. Go and read them, they're fantastic. I'm speeding up a little bit if you hadn't noticed. Tip number 4, tuning the server configuration. With really the main objective being avoiding the dreaded full GC. Of course, with Neo4j 2.3 released today, this is not going to be a problem anymore. We hope. Certainly it'll be a lot less of a problem, but it's definitely something that you need to focus on with your server configuration. Every server needs to be tuned for your environment somehow. At the very least, it's setting the amount of memory it needs to use in the page cache. And before you do anything else, my advice is to turn on the GC logging. If you haven't done that and you're trying to use Neo4j in production, go home and turn that on right now. Because anytime you talk to us and try to get some advice, we're going to ask you for things like the GC logs to understand what's going on in terms of memory use. We don't turn them on by default because they use up a lot of space. It logs a lot of information. So if you do turn it on, you do have to watch the size of the logs, that's all. Configure the page cache. As I mentioned, your objective is to use as much memory as you can without, of course, saturating the system. So you need to leave enough memory for everything else to work, but give as much memory as you can to the page cache because it'll get better. Leave some for Neo and leave some for the operating system. Yeah. I'm going to skip forward a little bit. Monitoring logs is very, very useful and important, and watch for those GC pauses, which will be reported in the messages log with some obscure message like application threads blocked for additional blah, 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 blah. That's the kind of thing that is usually indicative of the fact that you're getting pauses in the application. And these are the things you're looking for when you're going into production, because when those happen in a production environment, then you run into trouble. Moving forward. So, get your performance tests in, test, adjust your configuration, monitor, repeat that. And repeat that regularly. Repeat it before every release. If you increase the amount of data that you have, say you get 1 million more signups, do your tests again just to see how that's affected things, because it can make a difference. Tip number 3, get a cluster running. Seems pretty obvious. A lot of people leave this till really late in their process of going live with Neo4j. They kind of build everything on this single instance thing, and then right at the very end they're like, all right, now we'll deploy it to a cluster. That can be a problem because the semantics of a lot of things change, and you don't know what you don't know until it comes along and hits you in the back of the head right before delivery, and that can be a problem. And the reason for that is because distributed systems are hard. We find them hard, and we're building one. You guys are going to find it even harder because you just have to take whatever we happen to build. So the best thing is to embrace that pain as early as possible. So use a cluster in your development environments and in your staging environments. You'll learn some distributed systems. It'll hurt your head. It'll hurt, you'll give us some feedback about, things that are challenging, and together we'll figure it out. Yeah, I'll move forward because I'm running out of time. Don't assume you know how distributed databases work. There's lots of good information on our website you can go and read about and learn how they work. A lot of people kind of have these assumptions around how they work that we like to prove wrong for one reason or another. Don't be that person. There is great tutorials on our website for setting up clusters, which will guide you through this. And I was going to talk you through those tutorials, but I'll jump ahead. So the things you're trying to learn with clustering is basically understanding how data moves around. That's very important for understanding how the cluster is going to behave. How when you write data to certain places, it's going to move according to the clustering topology. We write to a slave, it gets propagated to the master propagates those out to all of the slaves. So I skipped through that part, but what I was building up to there was this one little pro tip as early as possible when you're designing your application, figure out how to separate reads and writes. And it's something that a lot of people don't do, and trying to retrofit that in later is really quite difficult. If you've got the opportunity, separate them early because that enables a bunch of optimizations in terms of how you talk to Neo. You know, certain servers in the cluster will be better for accepting writes. There's other servers that are going to be better for reads. Being able to separate those can be a really powerful thing, and most of our customers do this. So that's my pro tip. Tip number 2, pick an awesome driver. There are some great drivers out there. Java drivers, .NET Java drivers, JavaScript drivers, Python drivers, Ruby drivers, PHP drivers, more drivers than I can name. A lot of the driver authors are here today, so you can grab them as well. And as we announced this morning, coming soon, we're going to have a lot more. And we're going to have official uniform language drivers in the language in a variety of languages. So pick a really good driver and work with them, and get in touch with the driver authors as well, and understand their motivations and how they expect you to use that driver, and it'll make your life much, much easier. And then finally, my number 1 tip to conclude, have a relationship with us. I work at Neo Technology. We're the company who is on this mission to give you guys a better way to work with data. We want to help you be successful. So have a relationship with us, because that's going to make it much, much easier for you to achieve that success. It's much easier to take that journey if you're not alone. And it's much, much easier to adjust course early than it is to do it later, and we can help you to do that because we've been there before and we've seen a lot of other people being there before. And of course you've taken the first step. You're here today, you're listening to me, but connect with my colleagues. They're all here today. Email us, tweet us. We've got lots and lots of ways to get in touch. Don't be that guy who goes off and tries to build this huge system on their own using Neo and never talks to us until it doesn't work and then gets really sad and lonely at the end. We have this passionate world-class team, and we of course built Neo so everybody could have that success. We're successful when you're successful. We value relationships. Finished. Thank you.